that you know how to use some of the key system utilities on a Linux box, let's move on to show you how you can add users as well as groups on your system. So we'll label this section User Group Management. We'll do so with shell and GUI tools. And the features are pretty self-explanatory. Ability to control users and groups. Now we've got two basic tools for managing users, and that is the user add utility. So primary tools include, we've got group tools as well, but the user tool can also be used to manipulate group membership. User add, used to add users and modify group membership during user creation, as well as system config users, which is a GUI-based tool. We'll begin by exploring user add, the shell-based tool. So our task is to create a user named student1 using user add. We should also ensure that user student1 has a home directory beneath the home structure, which by default the Redhat user add implementation will take care of. Now, in order for this to work, we need to SU into the system. So we need to switch users into the root context to be able to execute user add. Then when we execute which user add, because user add is not in a standard user's path, we see that it's located beneath user sbin. If you want to know the package membership of this particular file, execute rpm query file, or QF, followed by the full path to the file. And we see that user add belongs to shadow utilities. Shadow utilities also provides the main database beneath etc known as shadow, which contains usernames and their encrypted passwords. So with that said, if you execute user add with no options, it returns the options that you may use to create your users, such as a base directory, a comment, a home directory, a shell other than the default, which is bash, so on and so forth. Which may lead you, if you're curious, to a question, and that is, where do the defaults come from? Let's note, default user settings, and basic group settings for that matter, derive from etc login.defs. So before we go off creating the student1 user, we should explore that file, etc login.defs, as it'll heighten our understanding of the defaults that are used by the user add as well as GUI utilities. So we've just used the pager less to take a look at this file. It's loaded with comments explaining each of the options. Now when a user is created, their mail directory will be beneath var_spoo mail, indicated by the user's username. So if we create a user named student1, student1 will receive mail to a file named student1 beneath var_spoo mail. We also see password aging controls. The maximum number of days, now in Linux terminology, 99,999 is also equivalent to infinity. In other words, this is the default way of saying the password never expires. You should think about the system policy whenever you set up new users and whenever you modify existing users. You can change global settings for new users by modifying this login.defs file. A more sensible value would be perhaps 45, 90, 60, or 30 days. But nonetheless, the default is set to a very large value. We'll leave it for now. The minimum number of days a user should hold on to a password is set to 0, which again is not the securest of options, but is the default. The minimum length is set to 5, and the warning age is set to 7. So 7 days prior to expiration, the user will be warned that the password is set to expire. Minimum maximum values for automatic UID selection. If you notice here, the UID minimum is set to 500. That means the first user created will be indexed at user ID 500. In fact, if we navigate to a separate shell as a user Linux CBT, We can see our UID, and it doesn't find it in the path, but we can grep Linux CDT from etc password, which is the default user accounts database, and as you can see, the first non-system or non-privileged user created, Linux CDT, has the ID of 500, which means the next user created will have an ID of 501. In other words, login.defs controls where users are indexed in terms of UIDs, and the same applies to GIDs. An upper limit is set to 60,000, so you can create users from 500 to 60,000, or you can create 60,000 minus 500 users, or 59,500 users on the system. You can always increase the limit if you'd like, if for some reason you need to define more user accounts, for example on an extremely busy ISP Linux system. We can ignore commented items, such as cron entries. Create home is set to yes. When you use UserAdd, the shell tool, to create a user, the user's home directory will be automatically created. And by the way, when we executed ID earlier, or UID earlier, we prefixed it with a U as opposed to simply ID. When you type ID, which is another command you should know, it tells you the currently logged in users, UID, GID, and any groups the user belongs to. So, this user's directory will be created, and the permission mask that will be set on files created by the user is 077, which means 700 for files or for directories, making the directories very secure. And one last option is set in the event that there are empty groups. By default, userdel will get rid of those groups if there are no more members, so that we don't have groups wasting precious GIDs. So there's your default file that governs the user creation process. It's etc login.defs. So back to creating our user, and that is the student1 user. We'll do so using UserAdd, followed by the username, student1. If you have specific settings that you'd like to have take effect, such as a different shell or a different home directory, you can indicate them. For example, to indicate a different shell, a shell meaning other than bash, indicate -s followed by the path to the shell. Perhaps a different home directory, -d. Let's move forward with the creation of student1. We'll echo the exit status. Doesn't seem as if much has happened. And that now means if we tail the contents of etc password, we'll see this new user, student1. Which leads us to our next point. So we've created the user. We haven't logged in or set the password yet. The next task is to set a password for the user. So set password for user student1. It's very easy to do. Just use the password command followed by the name of the user ID, which is student1. This will prompt us to set a password for the user. The user will be unable to log in until a password has been set, especially when using methods like SSH, which require, by default, non-empty passwords. So we'll execute password student1, and we'll set a simple password of ABC123. Notice that the PAM module, which is responsible for checking and setting the password, has complained that the password is very weak because it's based on a dictionary word, or a word that can be derived from characters from the dictionary, but it set it anyway. So now the user's password has been set. Now this leads us to another point. The standard user account databases, so user or default user accounts DB in a Linux environment is a file known as etc password. In there you'll find users, their corresponding groups, their home directories, references or a reference to shadow, and other items. Let's take a look at those items. We're going to navigate to etc and execute less, or we'll just cap the contents of the password file. We'll focus in on student1 and take student1's entry and break it apart. So for student1, we see the following. Username, this is the name with which the user will use to log in. shadow reference indicated by the X, which means whenever a login program such as SSH or login, which is connected to the TTY, authenticates a user, it will consult the shadow file for resolution of the user's password. The UID, this is auto-assigned and is usually the same as the GID in a Red Hat framework, and it begins with 500 for the first non-system, non-privileged user, which also means IDs beneath or below 500 are for system and privileged users. The next field is the GID, which references the primary group membership of the user, although a user can belong to more than one group certainly. The next field is a description field, also known as a geckos field. The next field is the home directory, and the final field is the path to the user's shell. So these are the fields that you'll find in the password file. Now, historically, Linux and Unix systems have stored password information in the second field of the password file. But etc password, and we should just note this, is a world-readable file. And by that we mean anyone who has access to the system can read the contents of etc password. So as a consequence, over the years, over evolution of Linux and Unix, passwords have been moved from etc password to etc shadow. So note, etc shadow now stores passwords in encrypted form. Also, etc shadow is not world readable. It's readable only by the root user and the processes which have access to authenticate users, primarily the PAM or pluggable authentication modules. So with that said, we need to take a look at, to get the full story of any particular user, such as student 1, the etc shadow file, because it also contains multiple fields. So let's cat the contents of shadow. We will find one entry per user found in the etc password file, and we'll extract student 1's entry. We could have done the same for Linux CBT, and then paste it. So fields in etc shadow, for example, includes username followed by, and it's usually MD5, but we won't list MD5 because it could be SHA or some other algorithm. So we'll just indicate encrypted password. So the ABC123 that we typed in earlier is represented by these characters, $ all the way through the terminating 0, and the